Hello everyone, how are you? Hope you're all doing fine. Today I will be teaching you guys O-level substitution reactions. Now, the challenge is that I'll be teaching you this in under 6 minutes. So our time starts now. First of all, this is a property of alkanes. Why alkanes? Because alkanes have single bonds between carbons and they're fairly unreactive. So, in order to change the hydrogen or to replace it, we only have to substitute it. Secondly, this only happens under UV light, and other than that, you cannot really substitute hydrogen. Lastly, this happens between hydrogen and a halogen. A halogen is something that is in group 7, such as chlorine or bromine. So it can only happen between hydrogen and halogen. Now this has 3 steps. The first one is initiation. What might be initiation? I'm going to explain it to you in just a minute. The second step is propagation. Last but not the least, the third step is termination. Before I go on to explaining initiation, propagation, and termination, I need to explain one other concept to you, which is of generating a free radical. Now, I'm sure you never heard free radical word before, but it's fairly simple. So basically, a free radical is something that has an extra unbonded or unpaired electron, right? So let me just write there, unpaired electron. Now take a look at this chlorine. Right? Imagine this is a chlorine. This is a Cl2 molecule. Okay, Cl2. So if this bond were to break, this consists of 2 electrons, right? So one would go back to this electron, and so this chlorine, I mean, and one would go back to this chlorine. Now what will happen is that 2 chlorine free radicals will form. As you can see, they both have one extra chlorine, and the same is true for any other compound. Suppose this is methane, right? If they were methyl, right, one hydrogen leaves, so this would have a methyl free radical because it has an extra free electron. Right, now coming back on to initiation, termination, and propagation. So what is initiation? Initiation is basically when an alkane reacts with a halogen under the presence of UV light to start the chain. Like CH4 reacts with Cl2, this would form CH3Cl plus hydrochloric acid. Now, the next step is propagation. Propagation is basically the chain part of the system or the mechanism, and inside this the chain continues until the reaction is finished. So after CH3Cl is formed, we react this with another Cl2 molecule, which would form obviously under UV light, which would form CH2Cl2 plus HCl. So remember, in each step HCl is formed and one hydrogen is replaced with a halogen. Again we follow this dot 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 dot, and then in the end what will happen is that you will have CHCl3 plus Cl2 UV light is must, and CCl4 will form plus HCl. So this CCl4 is actually the endpoint where we're aiming for. Last part, the termination. Now, what is termination, you might ask? Basically, termination is the part in which 2 free radicals combined, be it chlorine free radicals. If this happens, the reaction stops. See, Cl2 is formed, no more reaction progresses further. Suppose CH3 free radicals combined, right? 2CH3 free radicals would combine to form C2H6. Now this has made ethane. Again, the reaction has stopped. So now, one more thing I must add to this in order to conclude is that this is not a perfect method. Why, you might ask? Because you don't directly get CCl4 only. Okay, that's not the case. You will get stuff such as, like as I mentioned, CH3Cl, you'll get CH2Cl2 and CHCl3. You will get stuff like this, like them as well. So alongside this you will also get this, and that's why it's not a very perfect method and not a very clean preferable method. But that was all for O-level substitution. Hope you guys like this video. If you did, make sure to like and subscribe. All right.